I'll remind me at the end. I'll check it. Okay. We are continuing in lesson 1-3. For those of you here yesterday, I talked about the first 4 graphs, right? So when I say identity function, you need to know that it's y equals x, and it is that straight line, yes? Okay. Domain and range we talked about goes infinitely left and right, infinitely up and down. Then we talked about squaring function. When I say squaring function, you need to be able to come up with it's y equals x squared, and it is the parabola, right? That's infinitely left and right again, so negative infinity, positive infinity, the range, 0 to infinity. Then we had the cubing function. So when I say cubing function, you're thinking y equals x cubed. And you know it's that, I call it a squiggle. I don't know what you guys call it, but squiggle there. And then we talked about the reciprocal function. This is a newer one to you, right? Reciprocal function is y equals 1 over x. So know that. And then it's 2 curves going outward from each other. And when those 2 curves go out from each other, they run along the x and y axis. Okay? Yes? No. But you're just answering questions about these graphs. It's questions to get you familiar. Okay, so the next one, I guess I'll leave that out because some of you are trying to get yesterday's pieces, I know. The next one is the square root function. We graphed the square root function a little bit already this year, if I recall, unless I'm thinking about calculus. You guys remember what the square root function is? Or have you graphed it on your calculator and figured it out? It's what? Half a parabola sideways. Okay, so it's the top half of a sideways parabola sideways, which means it just goes from 0, 0, and out. So let's talk domain. Left to right. As you go left to right, what's the first x value you can use? 0. My graph starts at 0, 0. So 0 to where? Infinity, because my graph will go off right to infinity. So domain is 0 to infinity. Infinity always uses parentheses. Does my graph touch 0? Okay. It is a bracket. It does touch 0 because officially the square root of 0 is 0. I know it sounds kind of goofy, but that's what it is. Range. As we come up from below, where's the first x value? At 0, right? So my first x value as I come up from below is 0. Excuse me, first y value. 0 to what? My graph is going infinitely up. So that range is also 0 to infinity. Okay. Exponential function. You guys familiar with what the exponential function looks like? This one says y equals e to the x. And that's what we generally talk about when we talk about the exponential function. But that e could be replaced by any number. So this could be 2 to the x, 3 to the x, 4 to the x. It all gives the same graph. Have you guys looked it up? We did talk about a little bit in Algebra 2. But the exponential function runs along the x-axis coming from the left. The typical exponential function will cut through 1 on the y-axis, and then it curves up to infinity. Again, you can graph these on the calculator if you want a little more reassurance. But that x-axis is acting as an asymptote. So it's bounded below, if you want to use that vocabulary, it never goes below that x-axis. Domain. How far left does my graph go? It goes off to infinity, negative infinity. How far right does my graph go? As it turns and goes up, it's continuing to go right. So my domain is negative infinity to positive infinity. What about the range? How low does my graph go? Where does it first start? At 0, right? 0 to infinity. Does it touch 0? No, because I said 0 is acting as an asymptote. And so this is going to be 0 to infinity. These graphs aren't too bad yet, are they? I really haven't shown you anything. I mean, the reciprocal function is probably the one closest to you not being familiar with. Now, our next one down here is the natural log function. And officially, the natural log function is the inverse of the exponential function. I'm trying to think, did we look at log graphs when we talked about logs in Algebra 2? And I'm not sure we did. So, with that, the log graph is a new graph. Technically what it is it's this exponential graph reflected across the diagonal line y equals x, which, if we do that, do you need a pass or did they give you a pass?
They can give me a pass, but I think if I tell someone to
He'll be okay? Okay.
Yeah.
Let me know if so, or if, you know. Okay, so natural log function, it is going to reflect over that line y equals x. So what it does is it comes up from running alongside the y-axis, cuts through 1 on the x-axis, and then turns and goes off to the right. I feel like maybe I should have angled that up a little bit more, like I didn't angle it up very much. Yeah. Now, let's see, get this so you guys can see it. Something for me to point out. Notice, and I don't know, can you guys see that or not? Notice how I drew the graph versus how it looks on the graphing calculator. Can you guys tell the difference there? I drew mine going all the way down with an arrow, yes? What's it kind of look like on the graphing calculator? Kind of looks like it stops. FYI, it doesn't. Okay, the graphing calculator just doesn't always extend it. It just doesn't very well. So what you need to realize is it does keep going infinitely down. And it doesn't really show it. So that's one of those characteristics of the graph that you need to just be aware of. Domain. What's my domain? How far left does this go? Where do my x values start? The first thing we have is on the right side of 0, right? 0 to where? My graph is going off to the right, so 0 to infinity. Do we touch 0? No, because there's a vertical asymptote there. So parentheses, 0 to infinity. Range. How low does my graph go? Negative infinity. How high does my graph go? Yeah, it goes low to all the way low to high. So negative infinity to positive infinity. Okay. This bottom right corner are graphs that, these bottom 4 right are graphs you're not going to be familiar with. And that's, you know, that's fine. Although, I don't know, did you guys look at the graph of y equals sine x in geometry? I'd say not necessarily. I don't know that you guys look at the graph. So, sine x. First of all, your calculator, and it probably, very possibly defaults there, but your calculator needs to be in radians. Otherwise, it's not going to look right. But sine x, you just hit the sine button and the x button. And I'm actually, for my zoom, because this is a trig function, I'm going to do number 7, which is a z trig, because it shows you a better picture of what the graph looks like. This is the sine x curve. Okay? We will practice drawing this second semester when we talk our trig. But this is a graph we'll learn lots about. But what happens is this graph. The sine goes through 0, 0. It goes up as high as 1, comes down through pi, goes as low as -1, and then comes up through 2 pi. So it's those marks, because I have it on a trig function, those marks are, every mark is pi over 2. So every time it's going through a mark, it's 1 pi, 2 pi, so on and so forth. So this is a sine function. And I'm going to go a little bit off the graph. Because I want to show. So there's how I drew my sine. It goes as high as 1, as low as -1. Okay. Right here, like how far it is over here is -2 pi. How far it is over here is +2 pi. Like those are kind of the intersection marks. Obviously, does my graph just stop there at -2 pi and 2 pi? No, it keeps going. So that is the sine x function. It just, I don't know, is oscillate a good word for you guys? Goes up and down repeatedly. With that in mind, yes? I use the sine button, which is right there, just your sine, cosine, tangent button. I use the sine button, and then I had to put x in, because I have to put a variable in. If your calculator is not getting that, you might be in your mode might be in degrees instead of radians. If your view doesn't look like mine, and I did the number 7, a zoom trig instead of a zoom standard, which makes a difference too of how it looks. Okay, you're doing inverse. You just need to just do sine, because that's inverse sine. So clear that. I just clear the whole thing and just do sine, and then x. That'll do it for you. There you go. Anyone else not able to get a graph that was trying to get it graphed? Because it's usually just probably a couple settings I need to change. You need to change on your calculator. Okay, so that's sine x. Domain. How far left? How far right? Infinity. It's going to keep going up, down, infinitely left, infinitely right. So my domain is negative infinity to positive infinity. What about the range? How low do we go? -1, because each of the valleys are each touching -1. How high does my graph go? 1, because my valleys are each touching, or my mountains are each touching 1. Does that make sense? I'm going from -1 up to +1. So my range is -1 to +1. Am I touching these? Yes. It's not an asymptote happening. My graph is actually touching these. Do I need to zoom in? Are you guys able to see that okay? Sorry, I see some squinting happening back row, so does that help maybe? Okay, cosine. Guess what? Sine is a lot like cosine. And let's see, so to show it on the calculator, I'm just going to do cosine x. So your cosine button and an x. I'm already on zoom trig. What do you notice about cosine? Kind of the same, yes? Yeah. Yeah, so notice on sine, what did my sine do? My sine cuts through 0, 0. Whereas cosine cuts through 0, 1. It has a max at 0, 1. Okay, so that's the difference there. Really, sine and cosine are the same curve, just shifted differently. And in fact, if I have cosine graph there and then I graph sine, you'll see the difference. My red is my sine curve that's currently graphing. My blue is my cosine curve. So they are the same curve, just shifted differently. Okay, so for cosine curve, I'm going to start up here at 1, 0. and it still ends. I mean, if I draw one period on each side, whoops, it goes from negative 2 pi to pi. If I draw that, it goes as high as 1, still goes as low as negative 1. Domain. How far left and how far right do we go? Negative infinity to positive infinity? Okay, negative infinity to positive infinity, so it's going infinitely left, infinitely right. How high are we going? Yeah, why did I start with how high did we go? Okay, so let me rephrase that. How low, as we're coming up from the bottom, what's our first value on range? Negative 1. How high does my graph go? Positive 1. So domain again is negative infinity to positive infinity. Range again is negative 1 to 1. And obviously I wrote it without asking. Does it touch negative 1 and 1? Yeah. Yes, it does. Okay, you guys got that one? Okay. The last one I expect you to know. Absolute value. And if you say you don't know absolute value, please go talk to my Algebra 2 students right now. I taught them absolute value the last 2 days. So you learned absolute value a year ago. Do you remember what the graph looks like? A V. Not a U, but a V. Remember, it's centered at 0, 0. What do each of the sides of the V go? When we draw, it's usually like up 1 over 1, up 1 over 1. They have slopes of 1. So you learned absolute value. We did that in Algebra 2. Domain. How far left? How far right? Yeah, we're going infinitely left and right. So negative infinity to positive infinity. Range. How low does my absolute value graph go?
0.
Goes down to this point 0. Does it touch 0? Yes. So we're going to use a bracket. How high does my V go? Infinity. So this is 0 to infinity. Okay, grab your calculators for the next one. Okay, if you just type y equals x in your calculator, you're not going to get this graph. You're going to get a diagonal line. If you just put brackets around an x, those brackets just act as parentheses. You're not going to get it. Okay? What you need to type on your calculator, because this is the greatest integer function, there's a way. I believe I'm trying to think of places we can find it. I know it's on the math menu. But you will need to type y equals int x, int standing for integer. One place I know you can find it is on the math menu. No, not fn int. Well, no, I don't think that'll do it. Okay, so what you should do, be on your y equals screen, yes? And I'm going to go into math menu. On math menu, which math is right under alpha, I'm going to go over 1 to my num menu, N-U-M, and I'm going to go down to number 5. I'm going to hit enter. I'm going to put my variable in, so I'm going to hit my X button, put my variable in. And Shane said, is it going to be crazy? Is it supposed to be crazy like this? Yes. Now, I need to go back and do a Zoom 6 because I was on trig and I don't want to be on trig. So I've got even more stairs because my window just got bigger. Did you find it? So mine's in the math menu. I go over 1 to my num, and then it's number 5. I was thinking it might be in one of these shortcuts up there, but I don't see it. And that FN is not the right thing. That FN it. Okay, so it does look like stair steps, yes? Except, are my stair steps connected? No. I'm actually going to do a zoom in to kind of give you a better view. So you can see the stair steps, yes?
My stairs are connected.
Really? So you found int.
Yep.
See, yours is an older style calculator.
Oh, okay.
I'm guessing that's the problem. That's interesting. I don't know why they're connected. They're not supposed to be. That's interesting. So that's just something you need to make a mental note of.
Yeah.
That officially they are not connected. Okay. Yeah, if your calculator's showing them, Noah, yours has to do with the older graphics, and that's that's just how it is. I don't know because Jordan, yours is a newer calculator, so I don't know. Okay, so how long are each of these stair steps? 1, yes? Can you see that this stair step goes from 0 to 1? And then what do? We jump up 1. My next stair step goes from 1 to 2. You jump up 1. The next one's going to go from 2 to 3. The other thing I need to make a point of is we have closed circles on the left end and open circles on the right end of those. So, as I graph this, first of all, I'm going to label 1, 2, 3, -1, -2, -3. I'm going to go up and down 2 each. And then when I graph this, so what's happening here, guys, is I have a line on the x-axis that goes from 0 to 1. At 0, 0, it's a closed circle. At 1, 0, it's an open circle. From there, I jump up 1, so now I'm at 1, 1. I have a closed circle. I draw a line over to 2, 1. It's an open circle. Are you catching how this works? From there, I jump up to 2, 2. Closed circle, over to 3. At 3, 2, it's an open circle. Okay. You can also reverse it and go backwards, right? We go down to -1, open circle, closed circle. Open circle, closed circle. Now, with that in mind, before we talk domain and range, I want to ask you a question. Is this a function?
Yeah, I guess that's function.
Because it says function? Okay. Why is this a function? Because if it's a function, it has to pass the vertical line test.
Because of the open and close.
The open and close, right? And that is why, so my point in saying this is, I want you guys to realize it is important that the left ends are closed and the right ends are open. Because if they are both closed, this is no longer a function. Because they're on top of each other. So, okay, domain. X values. What X values are we using? He's right. Think about it, guys. Negative thing, obviously my graph keeps going, right? So we have to go infinitely out. Are we using all X values? Yeah, because always when you stop using an X value, you jump up to the next one and you continue using. So my domain is negative infinity to positive infinity. Range.
That's a tricky.
This is the tricky one. So when we talk range,
Negative infinity integers to positive infinity integers.
okay, so that's the gist of it. First, does this keep going on infinitely up and down? It does. So we know there's something infinite about it, right? But are we using all numbers infinitely? No, because we have numbers at 0. We have y values of 0. Then we have y values at 1. Did we use anything between 0 and 1? Y value wise? No. Then we have y values at 2. And so how I'm going to write is I'm just going to say all integers. Okay, because that insinuates infinite. So all integers. Okay, so yep, I understand what you're saying there, infinitely. Okay, and I would practice graphing this next one. Before you say you can't read it, because I get it, that denominator is small. This, it's called the logistic function. It's y equals 1 over 1 plus e to the negative x. So I rewrote that off to the side so you can see it. You'll be happy maybe to know that it's not nearly as funky as a graph. If you use a fraction bar, that's your best bet. If you don't use a fraction bar, it's 1 divided by, and then put that whole denominator in parentheses. 1 plus e to the negative x. Well, that didn't work. So notice I have that whole denominator in parentheses if I don't use the fraction bar. The other option, your better option, is to use the fraction bar if you can. 1 over 1 plus. Do you guys remember where your e is? It's down on the left there. It's the second function of ln. I'm going to do zoom 6. Is yours looking like mine? Okay. What's going on?
It's going from 0 to 1.
Okay. So as we look at this, I don't know if you guys understand what's happening or not, but this is running. It's running as you go off to the left. It's running along the x-axis. Yes, it's acting as an asymptote. When you get to the y-axis, it kind of crosses up, crosses through. And then it continues running along there. What is that value that's running along on the top side? And that is 1. So what's kind of happening, we've got a bounded function, if I can use that vocabulary, where it's bounded below by an asymptote on the bottom. That asymptote on the bottom is at 0. And then it's bounded above by an asymptote. That asymptote on top goes up to 1. So, domain. My graph goes infinitely left and right, so negative infinity to positive infinity. Range. Okay. Goes as low as 0, as high as 1, so that's 0 to 1. These are parentheses because they are asymptotes. We're not actually touching them. Okay. You need to become very familiar with those. We'll have a quiz next week over the first 4 lessons of the chapter, and we'll have a chapter test, okay? When it comes quiz test time, I'll talk about more how I'm going to assess those, but you need to be familiar with those. Now, as you flip to the next page, what's homework going to look like? Homework is going to be questions about these. Okay? So, what I'm going to say is we're going to answer as many questions as we can here, give you some examples. I may pick and choose, but we may not get through all of these. They're not good. They won't do it till 3rd hour, I don't think. Okay. So, example 1. Some of the questions are going to be pretty easy. Some of them are going to take a little bit more thought. It says only 2 of the 12 functions have points of discontinuity. Are these points in the domain of the function? So this is going to require you guys flipping back and forth, right? So 2 of the points have discontinuities.
Good morning, everybody.
everybody.
Good morning.
Good to see you all. I'm sorry to bother you.
You're fine.
I'm just going to grab this for now. She wants it.
Is her phone back there, guys? Or did she have it with her?
What's gonna happen?
I do need a strong man. I got it. It's okay. But I might need a strong man because I'm going to be bent over here, and the weight's going to pull me over. So you might have to pick my big old bed up off the floor.
Her phone is not back here, so she either has it or it's in her bag.
We'll take care of it. Hey guys, have a great day.
You too.
Bye.
you.
Love you all.
Okay.
Love you all.
Bye. We did reciprocate. You can say bye. You love your assistant principal as an assistant principal, right?
I was trying to get out of notes real quick, but she didn't find my number.
You're trying to distract her for, you were offering to be her big strong man? Okay. Okay, guys. 2 of the 12 functions have points of discontinuity. Do you guys remember talking about discontinuity back at the beginning of lesson 1, 2? Remember we had what? We had removable and non-removable points of discontinuity? Asymptotes and holes, yes? There's points of discontinuity, a break, a spot where I have to probably pick my pencil up, where that graph is not continuous. Well, it's not a yes or no. It says there are 2 that have points of discontinuity. So first of all, let's talk about which 2. Yeah, which 2 do I have to pick up my pen for? You guys agree? I cannot do one line to draw either of those. Huh? Right. Right now, I want to start by identifying which 2. Well, okay. So one of them was the reciprocal. And whether you write reciprocal or y equals 1 over x. The other one is the greatest integer. Now, we're going to have to answer these separately. When you write the equation for greatest integer, you can write that y equals x in brackets, or you can write y equals int x. Okay? But these are 2 different things that we're talking about here. As you look at the reciprocal function, first of all, where is that break at on the reciprocal function? At what value did we have a break at on the reciprocal? At 0, yes? Okay, so with that in mind, we had a break at 0. Is that in the domain? Well, technically, look at my domain. What was my domain? Did my domain include 0? Yeah, this is a technicality on the definition of continuity, is that 0, so is that point in the domain? No, it's not. Because the break is at 0, and x equals 0 is not in the domain. Okay. Now, which technically means that that graph is continuous on its, I can't remember if that comes up in homework or not, but this graph is continuous on its domain. Greatest integer. What was my domain on greatest integer? Negative infinity to positive infinity. Now, in this case, are these points in the domain? These points are in the domain. And this one, it is discontinuous, or there's a discontinuity at every integer value. So, discontinuity at every integer value. Yes. Because in this case, the domain is all real, and so the points are there. I'm not going to worry about the next part because the other part of that I wanted to talk about. Okay. Let's look at, as I said, I want to get a couple of these just to kind of get you guys an idea of what you might see in homework. Look at example 2. It says only 3 of the 12 basic functions are bounded, both above and below. Which 3? So bounded, above and below. So what are you guys going to want to have by your side when you're doing homework tonight? Your notes? Yeah, so you can look at the pictures. Okay. Pause. Sign. Is that bounded above and below?
Yes.
Okay. Sign is bounded above and below. It never goes above 1, below -1. Okay. What else? Cosine. Okay. And logistic. Remember, on the logistic, okay. On the logistic, it goes from 0 to 1, right? Okay. So you would have 3 that you would list. Now, what I was while I was distracted and trying to look in homework, is I was trying to remember how they're listed in the answer key. And they are listed in the answer key by the equations. Okay, so when I look at the answer key for tomorrow, they're listed by the equations. So the equation here, y equals sine x. Cosine x. And then this is the one, y equals 1 over 1 plus e to the negative x. Guys, I cannot stress enough to get in the habit of knowing those together. Okay? Don't just know logistic. Work on memorizing what that equation is, and vice versa. The next example says 3 of the 12 basic functions are even. Okay, guys, what do you remember about even? Okay, I agree, not odd, but symmetric across the y-axis. That is the easiest thing to remember here. So you need to go and look at your pictures. Which ones are symmetric across the y-axis? What do you got for me? I heard it. Someone say it. Squaring. Which squaring is y equals x squared. What else? Absolute value. Absolute value is y equals absolute value of x. Not sine, cosine. Where can I fold the y-axis in half? And it's the same on both sides, right? And that is cosine. So that's y equal cos x. So, where they're centered. Sine, I have this going through 0, 0. So if I fold this on top of each other, this lands on top of nothing, that lands on top of nothing. Cosine has a max there at 1, so when I fold that in half, it lands on top of itself. Okay? Unfortunately, I'd really like to talk about example 4, but we're running out of time. We are out of time. Okay, guys. Make sure you write that homework down if you have not. It is a little bit longer. Go through, answer all the questions. We'll come back and check them and talk about them tomorrow. And read the directions at the beginning of your homework very carefully about what they want.
Do you want to check this real quick?
I can. Let me finish.
With the tornado drill and everything, I don't think we're going to be doing anything, so I can stand by it.
Yeah, hold on here. Okay, trying to get the homework on the recording so it's visible.